Our second day on point slope form today, 2.7 day 2. So we're going to do some more with point slope form. We're going to take it a step farther today and talk about parallel and perpendicular lines. So we're going to make sure that we understand what the slopes of parallel and perpendicular lines look like. And then we're going to use that idea of parallel and perpendicular lines in order to write equations in point slope form. So that is our goal for today. So warm up here is just finding some slopes. So on each graph, there is a dotted line and a solid line. And so you need to find the slope of the dotted line and find the slope of the solid line on each of those two graphs. 4 slopes to find total. And hopefully this shouldn't be too big of a deal because you have been finding slope from a graph for a long time now. So if you haven't taken a shot at this warm up yet, go ahead and pause the video and do that. All right, so if you have, I look at number 1 and the dotted line here, I'm just going to pick out 2 points. I see those two. So my rise over run be rise of 2, run of 1. So my slope of my dotted line would be 2. 2 over 1 or 2. Okay, now let's see. We'll go green. 2 points on the solid line. I'm just going to find 2, maybe down here, just so I don't get in the way. All right, so rise over run for these two. Rise would be 2, run would be 1. So my rise over run is 2 over 1, or my slope again is just plain old 2. Okay, now let's look over at graph number 2. So here I have, let's start with dotted again. So pick out 2 points. I see a point here and a point here, right? So my slope on this one, let's see, rise is -1, run of 2. So the slope of this line would be -1/2. All right. How about my solid line? All right, let's see. I see a point here and a point here. And again, I'm not saying it, I guess, but remember, you could pick any 2 points that you want, and you should still end up with the same slope as long as you reduce. So if you pick different points, no big deal. We should still be ending up with the same slope. So if I pick these 2 points here, I'm going to do, let's see, my rise would be 2, and my run would be 1. So my slope for this one would be 2 over 1, or plain old 2. If you want to here. I could have written any of these as 2 over 1 if I wanted to. Okay, so hopefully you did a good job finding the slopes, but let's take a closer look here. If I look at my 2 lines in number 1, how would you describe those 2 lines? Well, some might say that those 2 lines never intersect. That would be true, right? They're not touching at all. But you might also say that these 2 lines are called parallel, right? Parallel lines never intersect. Okay. Take a look at those slopes. They were both 2. Because the angle of those lines are exactly the same. If the angle had changed on one of the lines, then they would be touching somewhere, right? Even if it wasn't on my graph. Oh, okay. Well, let's take a look at the graph on number 2. So over here you might say, oh, well on these ones, these lines are intersecting, right? They're touching, they cross each other. They're definitely intersecting lines, but they're intersecting at a very interesting angle. Do you notice that they're making that perfect corner, right? In fact, you might even use the little symbol that looks like this in one of those angles, right? And if you remember what that means that they're forming a right angle. So yes, they are intersecting, but they're intersecting in such a way that they're forming a right angle when they cross. And if you remember what the good vocabulary is for intersecting at a right angle, those are called perpendicular lines. All right, so perpendicular lines over here on number 2, check out those slopes. Are those slopes the same? Definitely not, right? Those are angled at 2 different directions for sure. But look, the dotted line is -1 over 2, and the solid line is +2 over 1. So what changed there? Well, it went from negative to positive, right? One's downhill, one's uphill for sure. And it flipped exactly upside down. 1 over 2 on the first one became 2 over 1 on the second one. The good math vocabulary for flipping upside down is called reciprocal. So there was opposite and reciprocal. And you just discovered two very important things about parallel and perpendicular lines, and that's how we're going to start here. So we just discovered that the slopes of parallel lines, those first ones on number 1 over there, the slopes of parallel lines were the same. The slopes of parallel lines are the same. And then we discovered over on number 2 that the slopes of perpendicular lines, those lines that cross to form a right angle, are opposite and reciprocal. So perpendicular lines, the slopes are opposite and reciprocal. So two things have to change for perpendicular lines. Well, you have to go from positive to negative, and then the reciprocal means flip, right? Positive to negative or the opposite, and then reciprocal means flip it upside down, right? Whatever that fraction is. And if it's not written as a fraction, remember, you always just put it over 1 and it becomes a fraction. All right. So let's see how we can use that idea. Notice here we are back to what we were doing yesterday. We're going to write these equations in point-slope form, right? And so I gave you that little hint of what point-slope form was again. Y minus y1 equals m times x minus x1. So in this first problem, it says write the equation of the line in point-slope form. It goes through the point 3, negative 5 and is parallel to the line y equals negative 1/6 x plus 2. So thinking back to yesterday, when I'm trying to write the equation of a line in point-slope form, I need to know m, the slope, and I need to know that point x1 and y1 that it goes through. Well, I see that I have a point here. So 3 will be x1, negative 5 will be y1. But what about m? What about the slope? Well, we just learned here that the slopes of parallel lines are the same, and this is asking me to write an equation to a line that's parallel to this one. Well, what's the slope in this line? The slope would be negative 1/6, right? This is y equals mx plus b. So if I have a line parallel to it, that means it has the same slope as this one. So that my slope must be negative 1/6. And then I have everything I need in order to write this equation in slope-intercept form. So my equation would be y minus y1 is negative 5, be careful, watch your negatives, equals m, which we just discovered was negative 1/6, parentheses, x minus x1 was positive 3. I do see that I have two negatives here, so I'm going to simplify that up to say y plus 5 equals negative 1/6, parentheses, x minus 3. There's my final answer. So we can write an equation in point-slope form really quickly if they tell us a parallel or perpendicular line. All we do with that equation over there is pull out what the slope is and then decide, am I keeping it the same or am I making it opposite reciprocal? And I ignore the rest of that equation completely. I use the coordinates for the point that they tell me in order to write my new line. Okay, so here's something similar, right? This one, write the equation of the line in point-slope form, goes through the point, negative 5, negative 2. This time it's perpendicular to the equation y equals negative 6/7 x minus 4. Why don't you pause your video and see what you can do on this one? Okay, so I see that I have my point again. So negative 5 is x1, negative 2 is y1. This time, I'm looking for a perpendicular line, right? So perpendicular means opposite and reciprocal slope. So here's M. This was B, right? I don't really care about B. All I care about is M because I have y equals mx plus b. So my slope of that line was -6/7. So if I want my slope for my new one to be perpendicular, that means my new slope has to go from negative to positive and flip it upside down to be +7/6. So the slope in that line was -6/7. A perpendicular slope becomes +7/6. And now I have everything I need in order to write my equation. So it'll be y minus, really watch the negatives on this one, -2 equals m, which is +7/6, parentheses, x minus x1, which was -5. All right, 2 double negatives in here, so definitely some simplifying to do. So I have y plus 2 equals 7/6, parentheses, x plus 5 as my final answer there. All right, so perpendicular, opposite reciprocal, parallel, same slopes. Okay, what do we got next? Again, writing equation of a line in point slope form goes through the point -1, -1, and is perpendicular to the line x minus 5y equals 15. Pause your video and see what you can do. All right, so our point again, jumping out at us, both x1 and y1 will be -1. This time, again, perpendicular. Oh, so I know that I'm doing opposite reciprocal slope, but what's the slope of that line? Oh, man. I can't find the slope when it's written like this. In order to find the slope, I've got to either be in point slope form or slope intercept form. Point slope form looks crazy on this one. I need to change this to y equals mx plus b if I am going to find the slope, right? Sorry. So I need to do some work before I can actually pull the slope out. So, okay, y equals mx plus b. So I'm going to have to subtract x from both sides. I get -5y equals y equals mx, so -x plus 15. Watch your negatives there. The x is negative, the 15 is positive. All right. Now let's see, I need to divide everything by -5. Those cancel. I get y equals, let's see, well, this is really like -1 over -5, right? 2 negatives make a positive, so I have 1/5 x plus 15 over 5 is 3. So y equals 1/5 x plus 3. What would be the slope in that one? Y equals mx plus b. We got it into y equals mx plus b now, so here is m from that equation. So the slope there was +1/5. If I need perpendicular slope, opposite reciprocal slope, my new slope would be -5 over 1, which equals plain old -5. All right, now I have my slope and my point, so I'm ready to roll here. Y minus y1 is -1 equals -5 is my slope, parentheses, x minus x1 is also -1. 2 double negatives to take care of here. So I have y plus 1 equals -5, parentheses, x plus 1 as my final answer for my equation written in point slope form. So remember, you have to be able to pull the slope out of that equation if it's going to be parallel or perpendicular. So if it's not in slope intercept form, you need to convert it into slope intercept form first. That's about as complicated as it gets when I'm trying to write in point slope form. All right, Here's the last one before we wrap it up here. Write the equation of the line in point-slope form that goes through the point 3, 1 and is parallel to the equation y minus 9 equals 2 parentheses x minus 3. Pause your video and see what you can do. Okay, my point this time, positive 3, positive 1, that'll help out. So 3 is x1, 1 is y1, and I'm going parallel this time. Parallel again means same slope. So that's good. Oh, now if I look at this equation over here, oh, that's not ny equals mx plus b. But wait a second. I believe this is actually written in point-slope form. Y minus y1 equals m parentheses x minus x1. It is. Now be careful. That's not the equation I want. I want a line that's parallel to that one, which means all I need that equation for is to pull the slope out of it. Where is the slope in an equation that's written in point-slope form? It's right here, right? So my slope of this equation was 2. I don't care about the rest of that, right? I needed to go through the point 3, 1. So all I know is that my slope is going to be the same as that slope. So my slope is also going to be 2. But then I ignore that equation completely. That's kind of a common mistake here. I kind of want to use those numbers. Nope, nope, nope. All I do is pull the slope out of that equation and then use the 0.31 that I'm given over here. So my equation will be y minus y1 was 1 equals slope was 2 parentheses x minus x1, which was 3. So this is the correct equation, and I did not have to convert that equation because it was in point-slope form. So just be careful that you're really recognizing what form your equations are given in. All right, guys, if you can do that, you can do anything out there in point-slope form. You've got this. So just a couple of hot tips. Remember, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. That means positive to negative or vice versa, and then flip it upside down. And then when you're writing the equation of a line parallel or perpendicular to a given line, only use that given line to figure out the slope and then ignore it and use the point that's given in the problem. All right, you've got some homework for tonight as well, doing those parallel and perpendicular lines. And don't forget to ask questions if you're getting stuck.